More complicated factoring. If I read the steps that Mrs. Armstrong has written there, what does the first step say? Factor out the greatest common factor, if possible. Is that any different than what we have been doing? No. So the first step is still check to see what they have in common. Do these two have anything in common? X. So if I took out an x, what would I be left with? X squared minus 64. Am I done factoring? Because what's this x squared minus 64? Difference of squares. Yeah? So I have x, and then let's see, I got to break this up into two parentheses. Square root of x squared is x and x. Square root of 64 is 8 and 8. Make one a plus, one a minus. Do I have another difference of squares? No, because I don't have an x squared, and not to mention the fact that 8 is not a square number. So I'm done right there. Okay? And we know that that would work even if I didn't remember this difference of squares method. I could do my snowflake and put negative 64 on the top, right? Because 1 times negative 64 is negative 64. 0 on the bottom, I get my 8 and negative 8, and you would go from there, right? What about this one? I can still take out an x. What's different about this one? That's really hard to see. What's left? I have x squared plus 64. Can I break that up? No. This is a sum of squares. And we can't do anything with that, because if I looked at my snowflake, I have a positive 64 on the top. I have a 0 on the bottom. And two numbers that multiply to get positive 64 and add to get 0 don't exist. Okay? So, because if I put 8 and 8, they're either going to add to get 16, or if one of them is negative, they're no longer going to multiply to get positive 64. Or if both of them are negative, they're going to add to negative 16. There is no way for that to be factored. So a sum of squares we can't do anything with. That's as far as we can factor, is just taking out whatever they have in common. Okay? So, let's look at this guy. Do they have anything in common? Probably. They don't have anything in common. They're not a difference of squares. They're also not a sum of squares. They are actually what we would call a sum of cubes. Why do I call them a sum of cubes? Well, because technically this is in the form of something cubed plus something else cubed. What is it that's being cubed to get you the first term? X. What is it that's being cubed to get you the second term? 4. I really like 64 because it's both a cube number and a square number. It's 8 squared or it's 4 cubed. So here's the deal. With a sum of cubes, there is a fancy formula that we have to use. So if you have something that is in this form, so if it is in this form, which this problem was, here is how it factors. It's going to factor into a plus b, and then a squared minus ab plus b squared. Yes, it's an ugly formula. It's the only formula you got to memorize, basically, because I'll show you how the next one is almost identical. So, where do these a's and b's come from? Well, it's whatever is being cubed. So I wrote them in a different color. This is what I'm going to put in here wherever I see an A. And this is what I'm going to put in wherever I see a B. Okay? So I had something in this form, so let's write the factorization. The first parentheses is going to be A plus B. Well, what am I using for A? x. And what's b? 4. So in other words, our a we're using is that x. Our b that we're using is that 4. Next parentheses starts with what? A squared. So if I take that x and square it, I have that. Minus a times b. Minus x times 4 is 4x. And then finally plus b squared. What is b? So 4 squared is 16. There it is. Now, once you have put stuff into this sum of cubes formula, most often, I can pretty much guarantee you, you're done. As long as you've taken out a GCF first, if there is one, you're going to be done with your factoring right there. Now, I'm sure you're going to be happy to learn that there is also a formula for the difference of cubes. Now let's go back for a minute. You can factor a difference of squares. You cannot factor a sum of squares. You can factor a sum of cubes and you can factor a difference of cubes. You can factor both when we're talking about cubes. Okay? So here is the difference of cubes. If you have something that follows this pattern right there, something cubed minus something cubed, here's how it factors. A minus b, a squared plus ab plus b squared. What's different between those two?
It's not subtracting by AB.
It's just the signs, right? They both have a, b, a squared, ab, b squared. Do you see that? The only thing that's different is the signs. Here's how I remember the signs. I remember it based on this acronym. SOAP. The first sign in that first parentheses is the same as whatever the sign was in the problem. So if you had addition in the problem, you have addition in your first parentheses. If you had subtraction in your first problem, or in the problem, you have subtraction there. So it's the same as the problem. What do you think O stands for? Opposite. The very next sign is the opposite of whatever that one was. So if it was plus, it's minus. If it was minus, it was plus. And then the third sign is always positive. In both cases, it's positive. So the first sign is the same. Second sign is the opposite. The last sign is always positive. Beyond that, you just have to remember the pattern of A, B, A squared, AB, B squared. Okay? So let's try a couple of these. This one right here, just like I was looking for sum of, or difference of squares the other day and said that it just had to be divisible by 2 for a difference of squares. In order to be a cube number, it has to be divisible by 3. That includes the exponent. I'm sorry, I misspoke there. The number has to be a cube number, so it has to be able to have the cube root taken of it. But the exponent has to be divisible by 3, was what I meant to say. So, is 8 a cube number? Is it something cubed? What is it? 2 cubed. Is 125 a cube number? Yes. What is it? 5 cubed. What are some other cube numbers? 27, because that's 3 cubed. 8 we've got here. 64 we had in the previous problem. Those are all cube numbers. And one number that people always forget, 1 is a cube number. It's also a square number. 1 is everything, right? So, this is in the form of something to the third. This time it's minus something to the third. So I got to figure out what those two somethings are. What is it that to the third power gets me 8? Okay, let me rephrase that question to get the rest of it. What is it that to the third power gets me 8x cubed? 2x. So when I use my formula, wherever there's an a, I'm going to plug in 2x. What is it that when I raise it to the third power gets me 125y to the sixth? 5y squared. Right? You divide that exponent by 3. So in my formula, wherever there's a b, I'm going to put 5y squared. So, which formula am I using? Difference of cubes. So my first parentheses is what? A, which is 2x, minus b, which is 5y squared. What's my second parentheses? It's going to start off with a squared. How do I square 2x? How do I square 2x? I have to square both the 2 and the x. So I end up with 4x squared. So let's see. Same, opposite, so this is going to be a plus sign. In the middle I have a times b. What is 2x times 5y squared? 10xy squared. And then always positive, so that's a plus. And now I have to square b. Well, 5 squared is 25. What's y squared squared? Y to the fourth. Yep. And there I go. So once you remember the formula, it's actually quite simple. Okay? Whew, look at this one. Now here's all these difference of cubes, sum of cubes stuff, and all of a sudden I give you a 2. That's not a cube number, is it? But I think 2 might be part of what they have in common. What else do they have in common? A y. So what would be left inside? X to the 18th minus what? 27. Is that a difference of cubes? Is 18 divisible by 3? Is 27 a cube number? It is a difference of cubes. So it is something to the third minus something to the third. What are those two somethings? What to the third power gives me x to the 18th? X to the 6th. And what to the third gets me 27? 3. Right? 3 to the third gets me 27. So let's plug this into the formula. Which formula am I using? Sum or difference? Difference. So, wherever I see an A, I'm going to use x to the 6th. And wherever I see a B, I'm going to use a 3. So my first parentheses is going to be x to the 6th minus 3. My second parentheses starts off with x to the 6th squared. How do I square x to the 6th? Well, that would make it x to the 12th, right? Plus that opposite thing. A times b. X to the 6th times 3 is 3x to the 6th. And then plus b squared. B is just 3, so b squared is 9. Now, I'm tempted to go box my answer, but I don't want to forget the fact that I took a 2y out at the very beginning, so it still has to be there up front. Okay? So again, once you've used that formula, you don't have to check if it can factor any further. Okay? All right, let's look at these guys. I see 4 terms. So clearly it's not going to be a sum of cubes or a difference of cubes if it's got 4 terms. Is there anything that all 4 of them have in common? Nope. So let's move on to what? Snowflake or grouping? Grouping. These two have what in common? X to the 3rd. What would be left inside? X plus 1. What sign do I bring down? A minus. And what do these have in common? And what would be left inside? X plus 1. So I have x to the 3rd minus 343. And I have x plus 1. X plus 1 is not a square or a cube because it's just plain old x. But this is a cube. Is 343 a cube number? So yeah, pretty much know up to 5. What is 6 to the third? 7 to the third? I have another difference of cubes, don't I? So I have x to the third minus 7 to the third right there. Do you get that? So that's going to go how? Let's see, that's going to be x minus 7. Then I square the x. I multiply x times 7. And then I square the last one, which is 49. And then this x plus 1 has to be a part of it also. So you may get some other problems of factoring that we've done before that you can actually factor further. Woohoo! Okay. Now, this problem we did the other day. We used our snowflake on this, and it factored into x to the third minus 8 and x to the third plus 1. And I said, we'll talk about how you can factor that further. What do I have here? Difference of cubes. What do I have here? Sum of cubes. See if you can break both of those down into what they factor into. So let's finish this one off. I have x to the third minus 2 to the third. So that's going to become x minus 2, x squared, there's my bell, plus 2x plus 4. And this one will be x plus 1, x squared plus 1x, I'm sorry, minus 1x plus 1. So that one factors to that whole thing. All right, homework's coming around. Happy studying.